Hello students, welcome to my channel. Today we are going to discuss about selection sort. In the last class we discussed about brute force method. It is nothing but straightforward approach for problem solving. It solves a problem by trying all possible ways. Selection sort is also one of the example for brute force method. So in this selection sort we will try all possible ways for solving a problem. This is known as in-place comparison sort algorithm. This means it will not use any extra space for comparisons for performing operations. It divides the given list or array into two parts. One is known as sorted array and another one is unsorted array. Initially, the sorted part is empty. Why? Because we need to perform the sorting operation, either ascending order or in descending order. The algorithm selects the smallest element from the unsorted list in each iteration. So in every iteration, it will select the smallest element. After selecting the smallest element, it will place at the end of the sorted list, at the starting of the sorted list. This process is repeated until we get a sorted list and there are no more elements left in the unsorted sublist. So I will explain this with algorithm. So this is the algorithm for selection sort. So first we have to set min to location 0. Min is one temporary variable that it will point to the 0th location. And then we need to search for the minimum element in the list. After finding the minimum element, we need to swap that minimum element with min value. So min is already pointing to 0. So we have to interchange min position element and minimum element. And next we need to increment minimum value to 1. Again we need to find out the next minimum element. We need to swap with first position. So this process repeats until list is sorted. Now we'll see by using example. This is the example. The array elements are 12, 29, 25, 8, 32, 17 and 14. So first we will take one min variable. It is always points to it. Starting it will point to the 0th position element. The 0th position element is 12. What is the next one? Next we have to find out the minimum element in this array. So 12, 29. When compared 12 with 29, 12 is minimum. 12, 25. When compared to 12 with 25, 12 is minimum. Next 12, 8. When compared 12 with 8, 8 is minimum. So by using comparison, we will find the minimum element. So in this case, the minimum element is 8. We need to swap the minimum element with 0th position element, 12. So if you observe here, 12 with 8, it is interchanged. Next, we will increment minimum value. So the minimum value now it points to the first position, that is 29. Again, we need to find out the next minimum element. The next minimum element is 12. We will interchange 12 with 29. Next, min is pointed to second position, that is 28, 25. Again, we have to find out the minimum element. The next minimum element is 17. Next, we will interchange with 25 with 17. So like this, we will find the minimum element and we will replace with minimum value. So remember, in each iteration, the min value is incremented. In each iteration, we will find the minimum element for swapping. So this process will repeat until we find the sorted array. So here it is the sorted array 8, 12, 17, 25, 29, 32 and 40. Now we will find the time complexity for this selection sort. So we will find time complexity and space complexity to determine the efficiency of algorithm. If it is taking less amount of time, less amount of space, we can say that algorithm is efficient. But in this case, given n inputs, this is the input and output is nothing but number of steps to sort the list of array. If we are given n elements, then the first phase it will do n minus 1 comparisons. Why? Because yes, in the first position, if the number of elements are 7, it will do 6 comparisons. 12 with 29, 12 with 25, 12 with 8, 12 with 32, 12 with 17, 12 with 40. In the next iteration, it will do n minus 2 comparisons. 29 with 25, 29 with 12, 29 with 32, 29 with 17 and 40. In the third iteration, it will do n minus 3 comparisons and so on. So the total number of comparisons can be found by n minus 1 plus n minus 2, that is n into n minus 1 divided by 2. We will ignore the constants and the time complexity is order of n square. So the best case time complexity. What is meant by best case? If the elements are already in sorted order, that is known as best case. The complexity is order of n square. Average case means the array elements are in random. That is also order of n square. Worst case, the elements are in reverse order. The time complexity is order of n square. And space complexity. I already told in the starting, selection sort use in place comparison. No need of any extra space. So that's why it will take constant space. Constant space is represented with order of 1. We are not using any extra space rather than two variables, namely min and I, for iteration. I hope it is clear. Thank you.